Welcome to the notes on the slope of a line. Something we've all heard before, slope-intercept form, but today we're really going to review and talk about what that means. So slope, all right, or the tilt of a line, as I like to think about it, we've got some pictures down below, is really the rate of change, okay? Slope equals the rate of change. Now, there's different types of slope. There's negative slope, and they talk about from falling from left to right. There's positive slope, again, which rises, but again, it's important from left to right. There's zero slope and undefined slope. So here's a picture of what all those look like. Again, positive slope. Notice as I look from it from left to right, L to R, notice that thing is going up. It's positive. This one, again, left to right, this one is going down. It's negative. And there's our zero slope and our undefined slope. We'll talk a little bit in a sec why that it's zero and undefined. But zero is the horizontal line, undefined is the vertical. So how to find slope? Okay, here's a little diagram here. So slope. All right, the letter that represents slope is the letter M. Okay, why do they use lowercase m? Because it's how you move on the graph. All right, slope is a ratio of vertical change over horizontal change. All right, remember vertical, that's our y, and then obviously our horizontal is our x. The other phrase some people like to use, and I love to use it, I still think of it as, again, you can also say that equals the rise over the run. Again, because the rise is the y and the run is the x. Again, I think you're seeing the point of y. Make sure to get y on top. And then algebraically, it looks like this. Slope m equals the change in y, which just means subtract the y values over subtract the x values, x2 minus x1. Again, you need 2 points in order to find the slope. So if we look at this example here, it says the vertical change. Okay, that is our y. Okay, there's our y. Vertical is y. And if you look at our y values, they took 5 minus 1. That's where this comes from right here. And then if you look at our horizontal change, that's our x value. And those come from right here, 4 minus the 2. So that's when you need 2 points, y2 minus y1 over x2 minus x1. So if we complete this, okay, we said 5 minus 1. So the slope of this problem would be m would equal 5 minus 1, which they said was 4. Okay, 5 minus 1 is 4 on top, over the change in x, which they said was 4 minus 2. So that's 2, 4 over 2. Well, that means that the slope then is 4 divided by 2. That's a ratio that equals to 2. So the slope of this problem would be 2. Let's take a look at a problem without the graph. And here's something they will ask you on the homework. All right, find the slope of the given line of the points negative 1, 2, and 4, negative 2. Remember, you need 2 points to find slope. So let's write down that formula. Slope again is m equals y2 minus y1, just a change in the y's over the change in the x's, x2 minus x1. So let's pick our points. All right, here's our 2 points. You got to call one your second point, one your first point. So I'll call this one my y2. I'll call this one my y1. Now, again, it doesn't matter which one you call which, but whatever you call y2, well, then that has to be x2. And whatever you call y1, that has to be x1. So now we just got to plug in the formula. So m equals y2 minus y1. Well, we said y2 is negative 2. It's always a minus sign. And then y1 is 2. So negative 2 minus 2 on top. And then on the bottom, we got to go x2, which is 4. Always that minus sign. And then what is our y value, or our x1? It's a minus 1. So now we just complete this. Negative 2 minus 2, well, that is going to equal negative 4. And that's over 4 minus a minus 1. 4 minus minus, this actually becomes plus. The 2 minuses become a positive. You got to watch that. So 4 plus 1 is 5. So this slope of this line is negative 4/5. Ratios or fractions are okay. Okay, let's see what else we're going to talk about. Slope-intercept form. So now that we know what slope is, how to find it, slope-intercept form. There it is. Y equals mx plus b. Okay, so again, the slope, why does they use m? Because it's how you move on the graph. And why do they use b for y-intercept? Because it's where you begin on the graph. Okay, and just remember, this is a y-intercept point. Okay, it's not just the y-intercept, so it's a point on the graph. So any y-intercept, it's when x value z is 0, and your y-intercept will be whatever B is. So remember that when you're doing these problems. M, when you get y by itself, the slope is the coefficient in front of x. So let's take a look at the first example. Find the slope and y-intercept point of each line. This first one is really simple. If y is by itself, it's already in slope-intercept form. So your slope is simply the number in front of x. So in this case, m is -2. Okay, then your b value, that's the term on the end by itself. So b, all right, it's a y-intercept point. So it's an ordered pair. So again, for any y-intercept, the x value is 0, and then the y value is 3. Okay, because that on the graph is where it intercepts the y-axis. Now let's take a look at one where y is not by itself. All we're going to do to get in slope-intercept is we have to get y by itself. We're solve for y. Some people want to just look at this and think that 3 is the slope because it's in front of x, but that only works once you have y by itself. So to get y by itself, let's do this problem. Let's subtract 3x to the other side. Let's subtract 3x. Now, when you rewrite this, all right, it's going to be -4y. All right, it's going to be equal. Now, we want to put the x in front of the 4. So we're going to write -3x. And since this is a +4, we're going to put +4. That's a really important step because the slope-intercept form, we want the x term in front of the constant term. Now we almost have y by itself. The last thing we need to do is divide everything by -4. What you do to one side of the equation, you got to do to the other. And remember, you're dividing every term by -4. That's really important. So then your final answer is going to be y equals, because again, that cancels out. -3 over -4, right? Negative over negative is positive. So keep it as a fraction. 3 over 4x, and then +4 over -4, that becomes a -1. So then our slope is going to be 3/4, because now that y is by itself, it's the number, it's the term in front, coefficient in front of x. And then our b is going to be -1. So we want to write that as, we got to write that final answer then. M equals 3/4. B, again, that needs to be an ordered pair, 0, -1. All right, on to the last topic we want to talk about is parallel and the slope of parallel and perpendicular lines. If you get slope of parallel lines, it's pretty simple to see here. Slope of parallel lines are the same. 3/4, 3/4. You can see why. If you go up 3 over 4, up 3 over 4, up 3 over 4, those lines will never intersect. So when you're solving for the slope and you see that they're the same, you know that lines are going to be parallel. It's that simple. Perpendicular, again, remember opposite. All right, perpendicular lines, first of all, form that 90-degree angle. We've already talked about that. The slopes of perpendicular lines are opposite reciprocals. Opposite refers to the sign, and reciprocal means we're going to flip the fraction or the ratio. Okay, so if you look at this example, the first one, the line going up in red here is 3/4. Well, that means that our other slope has to be the opposite side. This is positive, so I know this is going to be negative. The 4 was on top or on the bottom. Now it's on top. So that is what opposite reciprocals look like. You're going to find the slope the same way, but if you notice they have opposite reciprocals, you know the lines must be perpendicular. Okay. Now just a couple more. Let's just practice the opposite reciprocals. If I have a slope of 5, and I want to say, hey, what is the slope of a perpendicular line? Well, since this 5 is positive, I know that my new slope needs to be negative. And since 5 was on the top, it goes to the bottom. But what's this 5 really over? Well, that's really over 1. So that needs to come to the top. So opposite reciprocals, opposite sign, the reciprocal part means flip. Let's do one more. Let's say I had negative, let's go 4/7. What would be the opposite reciprocal? Well, since that was negative, the new one's got to be positive. 7 was on the bottom. Now it's on the top. 4 goes to the bottom. That's how you do opposite reciprocals, and those are for the slopes of perpendicular lines.